AI is moving out of the chatbot window directly into enterprise workflows. Autonomous agents now read databases, route communications, and execute tasks without human intervention. But when these agents operate in mortgage lending, healthcare, or finance, they hit a strict compliance wall. Regulatory frameworks like RESPA, HIPAA, and SEC dictate exactly how communications are handled. Current AI compliance tools focus entirely on the model layer, testing for bias inside a sandbox. But auditors require compliance at the action layer. Knowing a model is fair internally doesn't answer the auditor's question. They must know what it explicitly executed. When an AI agent sends a message or triggers a workflow, compliance teams must answer three distinct questions. Who delegated authority to the agent? What exact millisecond did it occur? And what was the precise payload? If a firm cannot provide cryptographic, undeniable answers to those three questions, deploying AI automation carries massive, unquantifiable liability. This is the problem solved by Thread. Thread is a sovereign AI attribution stack designed to capture and lock an immutable record of every action an AI agent takes. It is built natively on the Hedera public distributed ledger. By using Hedera, Thread physically separates the AI's predictive engine from its legal accountability record. A safe model means nothing if you cannot prove what it did. You need an external, immutable audit trail to prove real-world compliance. The first layer of the Thread stack is the event capture system, called the Spider protocol. When an AI agent initiates an action, the Spider protocol intercepts and strips it to build an attribution record. This contains the agent's ED25519 identity, action type, and human authorization chain. The record drops onto the Hedera consensus service, locking a Byzantine fault-tolerant timestamp. Writing this to a public ledger creates an immediate conflict. Regulated industries cannot legally store raw personal data or health information on an open network. Thread solves this using a SHA-256 payload hashing mechanism. When the Spider protocol processes an action, it reads the content but only records its cryptographic fingerprint. The raw text is discarded, and only the hash is submitted to the Hedera timeline. This architecture satisfies GDPR's right to erasure and HIPAA restrictions. The actual content stays secure in the enterprise's private systems, but the mathematical proof that the action occurred is permanently frozen. Payload hashing gives operators absolute certainty an action is verifiable without exposing the underlying private data. A linear log of time-stamped actions is useful, but complex compliance audits require relational context. You must know how events and agents connect over time. The second architectural layer is the web graph. Nodes represent AI agents, human operators, and enterprise systems, while edges show lines of delegation and causation. Built on EVM-compatible smart contracts, the graph periodically drops a tamper-proof snapshot to the HCS timeline for a permanent backup. Connecting the capture layer and the mapping layer requires an access control system. This is Layer 3, Vault Economics. Originally modeled on an XRP-inspired capacity system, Thread was rebuilt natively using Hedera's HBAR tokenomics. Operators manage their infrastructure access through HBAR-denominated capacity vaults. Many networks use fluctuating load fees that make enterprise budgeting impossible. Hedera operates on a fixed USD-denominated cost of 1/100th of a cent per transaction. The decision to build on Hedera also creates deep institutional alignment. IBM sits on the Hedera Governing Council, forming a direct bridge between the Thread infrastructure and the IBM Watsonx AI ecosystem. The combination of EVM relational mapping, fixed cost throughput, and Fortune 500 governance gives regulated enterprises a commercially viable path to scale. To see how this architecture functions in practice, we look at the IRES 360 real estate platform. Historically, deploying a new compliance policy across a brokerage means drafting documentation, retraining the field agents, and manually auditing thousands of emails to check for adoption. IRES 360 eliminates this bottleneck by explicitly decoupling the AI's creative drafting from the strict regulatory boundaries. Look at this interface. The highlighted section is the message. This is dynamic, contextual text written by the Watsonx engine based on a lead's CRM score and their current stage in the sales cycle. This lower section is the frame. It is an unalterable compliance wrapper containing the agent's NMLS ID, state licensing, and mandatory affiliated business disclosures required by RESPA. The workflow requires zero manual bookkeeping. A human agent applies a tag in their CRM. The AI engine instantly generates the dynamic message, and the system automatically enforces the locked compliance frame. This creates massive scalability. A single administrative edit to the legal frame instantly updates every future outbound communication across the entire enterprise. Separating the AI's contextual intelligence from the legal framing allows an organization to multiply their output without exposing themselves to regulatory drift. The value of that separation is permanently captured the exact millisecond an Iris 360 email is dispatched. As the email leaves the system, the spider protocol activates. The message passes through the spider filter, shedding raw text while extracting necessary metadata. The payload hash and human-to-agent delegation chain drops straight onto the Hedera timeline, locking into the permanent audit record. The result is a dual outcome. The consumer receives a highly targeted, compliant message sent directly from a local inbox, and the enterprise retains a mathematically undeniable audit record. This demonstrates the complete complementary stack. Watsonx governs the model's internal logic and safety, while Thread governs the external liability of the action itself. For regulated verticals, this resolves the primary adoption bottleneck. AI deployment transitions from an unquantifiable legal risk into a provable, governed operational asset. This entirely sovereign workflow executes on a public network, co-owned and governed by the Fortune 500 institutions that face these same regulatory demands. Realizing autonomous scale at the enterprise level requires an environment where every AI action is strictly governed, cryptographically proven, and permanently undeniable.